Hello, everybody, and welcome to our webinar on HVAC basics for home automation integrators. We're happy to host you here today. And our leading host today is Arkady Cherniak, our VP of Sales in North America, and he'll be the one delivering you with a presentation of 40 to 45 minutes that will focus on the topics that interest a lot of the home automation integrators when it comes to advanced HVAC system integration. Arkady, you're welcome to take it away.
Thank you, Vicky. Hello, everybody. I'm glad to host this event this time, and we'll jump right away into the main topic, which is the basics of HVAC and home automation systems integrations, which is mostly targeted at home automation integrators who are facing these projects of that challenge them to integrate between such systems. So the topics we'll be addressing today are: what is actually the HVAC? How does it work? What are the system differences between different HVAC systems, the ones that you face to integrate with? And what are these integration challenges? And then I will touch a little bit on the solutions that we as a CoolAutomation propose to help with these integrations to make them successful. We will then address a little bit of questions that commonly asked when integrators attempt to integrate between these projects. First, I'll address a little bit our own ID card, I would say. We were founded in Israel more than 13 years ago. We are still privately held and funded. We do the solutions for integration and control and management of the services that pertain to the HVAC systems. That is our specialty. And with that, over these years, we expanded to more than 90 countries worldwide with more than 100,000 systems installed and still growing very much. But we'll now go into the main topic. So what is the HVAC? The HVAC system basically is what you see here in the picture, that all of the HVAC systems, all the new, advanced, modern, or legacy systems, all have the same principle. They have these basic components that split between two parts of the system, the outdoor part and the indoor part. In the outdoor, you would see the condenser or the outdoor unit as it's called. And inside the house or the facility, you would see different key components, which are, of course, the thermostat, which is used to control the system, which is where you as the end user would enter your set point or the requirement, what you want the system to do. There will be the fan blowing the air at you at fast or low speed. And there will be the evaporator, which will be handling some internal functions of cooling and heating the air flowing through it. But these are the main components that will be common and will be found in any HVAC system, old or new. But that's actually where the differences start to appear. And we will look at two different types of systems, the traditional ones and the advanced ones, the inverter systems. Me representing the US, where I usually work. So I will address the traditional systems common to the North American market, but they are also found all around the world. These are the fan coils, the packaged rooftop units, the chillers, and they have their own thermostats that look as the good old standard thermostat. Some of them are nice looking, like with digital displays and touch screens, but still there are still good old thermostats that control the system on and off. And that's the huge difference between these traditional systems and the systems that you see on the right, the split systems and the VRF systems. These are very advanced systems. The main differences between them is that the advanced systems communicate. They use refrigerant instead of water like used in the traditional systems. And the big advantage of them is the comfort they give the end user and the energy they save. But when we talk about integrations, the main difference is when you need to communicate with these systems. And these systems do communicate bidirectionally. Like you expect nowadays modern systems fitted with computers to communicate with your automation systems. And that is the challenge. Specifically, the challenge would be lying exactly in the difference between how to control these systems. So if the traditional systems, well, for communication, I would say you use the brains and some means, it's called protocols, to communicate. So in case of traditional systems, the brains are actually in the thermostat. Yes, that little device on the wall, that's the brain of the system. You tell the system, the thermostat, that you need your 22 Celsius degrees or 20 degrees, you want certain fan speed, and that device will control the traditional system on and off and until it reaches that target. The advanced systems, the inverter systems, the VRF, the splits, they use also similar to a thermostat, but it's a controlling device. It's not really a thermostat. It's just the user interface for the end user to control the VRF system or the split systems, just to let the user enter his requirement into that system. So that system will make its decision internally how to reach that target. And that is the big difference. That system has brains, which is not in the thermostat, but it's inside the system, inside the indoor unit and inside the outdoor unit. And it will be making its calculations in order to reach precisely and quickly to the target point entered by the end user through that end user device. Now, that user device is a communicating device back and forth between the user and the system, which means it's communicating two ways. That is done and enabled by a two-way communication, which means you send a command and you get a feedback. The system reports with something, maybe an error, maybe some notification, and then you as a user can see on the screen of the controlling device that it tells you something, and then you act upon that, or it is smart enough to do something upon those conditions. And that is the big thing. The traditional systems are using one-way communications, which is send and forget, and then you hope that it will reach the target. While the advanced systems we are talking here about use two-way communication with the feedback. And based on that, we reach this challenge that we need to overcome with these thermostat. Of course, the end user would say, hey, wait a minute. We have these new nice looking thermostats. Why not use them with these advanced VRF systems and split systems? They're also smart, right? Well, that's not precisely so, because the new thermostats are maybe looking smart, but they're still communicating one way, and they are not doing exactly what the original thermostat of the smart system is doing. They don't have the same feature set. Let's say they don't have several fan speeds. Like on the new system, you would see 3, 4, 5 speeds. On that one, you will just have on, off for the fan. It will communicate only one way. It will not report errors. And there are other electrical differences between them. So you cannot just connect a standard thermostat to the new type of system, the split system, the VRF system. And that's what you would usually see in different projects, that people will expect to do this kind of implementation and expect you to integrate it. But before that, in small projects and medium projects, you would find the split systems. They look like this. They have the outdoor unit that will hold, let's say, up to 10 indoor units that look like you see here, and you definitely saw this around different houses, offices, and so on. And they will have these kind of devices, either infrared or on the wall wired controlling device or wired thermostat. The bigger projects would have, for large and high capacity, they would be called VRF systems. They would be managing much more units. It could be 50, 100 indoor units for large installations, for large facilities. These are even more advanced systems, but like the split systems, they also communicate and even better. So when you address these different projects, the best way is to understand the specifications. And that will lead to the winning solution for integration. So there are four basic approaches, or not approaches, but boxes to check before planning and integration with the project. What will be the system that you need to integrate? Is it a multi-split or a VRF? Is it a heat pump or a heat recovery? Is there a building automation management system or other type of automation system that need to be integrated with? That means you just ask for the equipment list of that project. Then it's important to understand where is it going to be? Is it a private home? Is it an office? Is it a hotel? Is it a restaurant? And so on. Or what kind of project is it in terms of operation? Is it a new build or maybe it's a retrofit? So the system layout and the design will be influenced by the nature of the project itself and the application. Is it private home or an office? That will automatically imply who will be the users. So if it's a private home, it's a family. If it's an office, it's some commercial application, employees, and that will definitely imply and influence what kind of usage there will be. So what kind of user expectation, who will be using that and how they will be using that. Will thermostats be needed or only the remote application will be needed? Will there be a home automation or building management system used for that? So that will imply what is the user experience to be expected. And that will definitely influence how you need to integrate and what the customer will expect to see as an end product. Speaking of customers, the thing is eventually boils down to, is it comfortable? So, which means how is the climate in the facility for the end user? And that means, first of all, the temperature. There are other parameters, of course, like the humidity and other aspects, but air quality. But the most important, number one question is the temperature. And that is done by sensing the temperature. These systems are very smart. The old style systems, the traditional systems, they use only the thermostat to measure the temperature in the area where the thermostat sits on the wall. If it's on the back wall, it will measure it over there. If it's in the front, that's where it will measure it. In the case of the newer system, the advanced systems, it has a set of different sensors spread around the facility, and they can be or cannot be used upon the choice of how precise you want to measure it. So the indoor unit has its own sensor, which is called return air sensor. It will measure, it will be up in the ceiling or high on the wall, and that is the area where the indoor unit sucks back the air from the space, and that's when it measures that temperature. So that's one indication. Second indication would be by the control panel on the wall, like the thermostat, it will also measure the temperature in the space. So these two main measurements will provide a much more precise measurement for the system, and it will be capable to reach a very high precision type of result. Sometimes you will have a customer, let's say in a high-end home, luxury designed, and they just say, you know what, I want clean walls. I don't want to see any thermostat. So then you would hide away this on-the-wall thermostat into some closet. And what then? So you will be measuring the closet temperature, which is of course not the idea. In that case, you would use a remote sensor. So there are different ways to overcome different requirements and how to address them that still the end user feels comfortable and is happy about the eventual deployment of the solution. And that is basically how it goes. You focus on what is important to reach down to the final result to satisfy the customer. You get the HVAC equipment list in order to know what type, what kind of system, how is the layout, and so on, as we mentioned earlier. Then you use some integration means to communicate between the HVAC system and your home automation system or any kind of automation system. I will talk about our devices, the CoolAutomation devices that help you get through this problem or challenge much quicker and more efficiently, elegantly, and quite important, cost efficient. So then you as an integrator don't have to chase after the HVAC person, and you can focus on the customization and to focus on the user preferences of the customer to make him happy eventually. And that will be done by just applying the solution that we as CoolAutomation can provide to overcome this challenge easily and focus on what you need to. In that case, it's basically three types of things. The usage issue that will be dependent on the outcome, on the successful outcome of the project, is once the communication barrier has been overcome by using our devices, you would be able to address the multi-brand situation. There are many times that, you know, this week you have a integration with, let's say, a Daikin VRF system, and the next month you have a customer with Mitsubishi or LG or any other, Fujitsu, Toshiba, doesn't matter. We support them all, and I will address that a bit later. Then there are different types of systems. Sometimes a house or an office will have both the VRF and the mini-split or multi-split system. We can combine between them. So you don't have to either eliminate one of the systems because you just don't know how to integrate or don't have the means to do that, or maybe it's expensive, complex. We resolve that. So it doesn't matter whether it's a different brand or if it's a different type of system, we can consolidate the controls of all of them. And then sometimes the customer can come and say, you know what, I don't want only to use your Savant, Control4, Crestron, or any other home automation system. I also want to use maybe Amazon Alexa or Google Talk Assistant. We can do that as well. So you have a much richer means and portfolio of solutions to offer the end user. The way we do that, it's by means of basically three types of integration products that we offer. These are our products. On the left side, you see the Cool Plug and Cooling Hub set. These are for mini multi-split systems. The one in the middle, this is our, I would say, flagship, the Cool Master Net. That's the universal device to integrate with any VRF system currently in existence. And we all the time add more and more brands and models and so on in order to integrate with the wide range of different home automation and other automation systems. And the cooling bridge is another device that helps to integrate zone control systems, fan coils, chillers that sometimes you do find in certain projects, coexisting with the advanced systems as well. So we can address that as well. So basically, if you look at a VRF project, you would use a Cool Master Net. So the HVAC system would be of any of those brands that are listed here, from Daikin to Samsung, Fujitsu, Toshiba, Mitsubishi, and so on. We will not waste more time on reading all these logos. It will provide you a very clean and smooth and, most important, native integration with all the manufacturers' home automation systems. That is done by all these brands developing a special driver to talk to CoolAutomation, which means we talk the native language of the HVAC brand and we talk the native language of the home automation system. So there are no conversions here, no backnet needed, no additional conversions which are degrading the performance and so on of the system. And of course, if you need also to provide some BAS or BMS type of solution, that is possible as well, because we support both Modbus and BACnet and KNX and so on. In a similar fashion, all these integrations are possible as well, but also with split systems for small and medium capacity projects where these kind of systems are used. You would use not the CoolMasterNet, but you would use the cooling hub and the cool plug combination. And on the right side, you will still have all the same functionalities for integration with any kind of automation system. On the cooling bridge, of course, these are more vendor and model specific. So for this, I would advise to contact us and consult with our technical experts, because on different combinations of systems, there could be a different set of solutions, basically around the cooling bridge, but we need to assess which type is it exactly, and we will advise on the most efficient solution for you. Eventually, the idea is that we would lead to a easy and efficiently quick installation, pure plug and play. You don't really need to configure anything. It's just the system auto-detects the HVAC system, and the profiles set into the home automation system auto-detect the CoolAutomation device. So you have practically nothing to do on our devices. And the benefits you would use from that, because of the bidirectional communication, you'll get the error codes, you'll get the notifications, your system will be able to respond to any of these notices and will provide a better quality of usage and user experience to the end user. You get the multi-brand support and you get the smart integration. All this in principle by this kind of connectivity. HVAC on one side, automation on the other side, some smart home devices to throw in to spice up the things a little bit. And any of our solutions will enable these connectivities. Just a bird's eye view on our total offering before we part ways, in this session. This is our, I would say, ecosystem of solutions. In principle, we would have the edge device that you would see in the middle. It would be the CoolMasterNet or the other products that I mentioned earlier. They would communicate natively with some automation system that you see here in the home automation building management system. Or it will talk to any indoor unit of the split systems. It can feed in different sensors and integrate with other systems that are not necessarily VRF or split, using the bridge that I mentioned before. And we can bring all this into the cloud. We have our own cloud. It is stored on the Amazon cloud services. And using that, we can provide also a set of what we call the Cool Apps Suite, a set of applications that we provide to end users, to service providers, and to facility managers. And that allows remote controls of systems, HVAC systems, of course, in what we are talking here about, supplementary to the automation systems that are used to control them locally. So that is also a capability and possibility to do so that we provide. Additionally, we can integrate with the Google and the Amazon speech control devices for smart home assistants. Additionally, for custom-made automation projects that are not using the brand names but develop their own, we also have the API, a special API to integrate between us and any third-party app that will be using this API to control the systems. That pretty much sums up what we have to offer today. Of course, we develop more and more, so stay tuned for future updates. But for now, I will ask Vicky to share with me any questions if there are from users who attendees to this session. Vicky?
Yeah, so thank you, Arkady. I think that was very informative, and more will also follow once we further on develop our offering. But our main questions that I see popping on the Q&A side of things are mainly compatibility questions, a lot of questions about Daikin, around Mitsubishi. What would you say to support those questions and to give them the best answers that you can?
It's two ways, okay? One is the rule of thumb. If it's a VRF system, you would usually approach it with a CoolMaster net, and 99.9, I'm a bit cautious. I don't want to say 100%, so I would say 99.9% of those, any brand and model is supported by us. The second part that I said, it is always recommended to consult with our specialist simply by sending that equipment list that I mentioned. Once we get that, in less than a day, usually it's less than an hour, knowing our, you would get a response saying, yes, it is compatible with this or that, or you need to also use this in order to get even a better or more efficient solution by maybe economical perspective or maybe performance of some kind. If it's a mini split or multi-split situation, we definitely need to see this. We also support most of the brands and vendors, but the problem is that there is a very large number of different indoor units that differ region-wise. So if it's from Europe or from Asia Pacific, or maybe from North America, South America, any area of the world, they have each vendor has its own set for that region. That usually most of it is common to the rest of the world, but some models are a little bit different. So it's better for us to know what is the part number.
So you would actually recommend the integrator to deliver the list of equipment, including the model numbers and the part numbers?
Yeah, even to take a picture of the nameplate on the unit. That's it, you know.
Yeah, okay. I had here a question about what we usually call the hybrid installations. That sounded very interesting and compelling to some of the viewers, and we were requested to dive a little bit into that.
Right. There are three types of hybrid. One is when you have hybrid between brands. So if you have, let's say, an existing office, let's say catching maybe 2 floors in a building. Okay, and then the company is successful, they're expanding to additional floor. But the first 2 floors were covered by, let's say, Samsung VRF. And they say, okay, but the floor that they're renting to us, you know, the 3rd floor is Daikin. What we're gonna do? How do we? So for that, very easy. A single CoolMaster net can support 2 or even more brands. Capacity-wise, it can reach up to 256 indoor units. This is huge. Brand-wise, one port is configured for Samsung, the other one will be configured for Daikin. And then both floors are consolidated in controls into one set of controls. So that's number one hybrid. Second type of hybrid is the same office, but the machine room, the IT room has, you know, all the computers, the servers of the office. It has a split system, and it could be even a different brand. So for example, you have that Samsung for the office, but there is a Fujitsu mini split taking care of the IT room, which is protected and not to be touched by anyone. So we can definitely provide the Samsung with the CoolMaster net, and to put a cool plug for Fujitsu in the IT room and tie it into the CoolMaster net, and then that becomes as one system. The third type is of hybrid is when you have a mix of legacy or traditional systems with the new ones. So a VRF and let's say a rooftop. So we have a solution for that, as I mentioned, let's say CoolMaster net as usual, and the bridge, for example. Again, it's very much recommended to talk to us, especially in such hybrid cases, because there are some nuances that we can, maybe from experience from other places, can propose something even better. Okay.
Yeah. Okay. I think that's about it in terms of questions. Let me double check. Yeah. Yeah, I think we've succinctly answered everything that we could. I would like to thank Arkady for his time and you guys for attending. We know how valuable your time was, and we hope that your time was well spent with us. You're more than welcome to contact us through our website, through our contact forms on the website, and consult with our team of specialists that will be more than happy to answer any of your possible questions that we might have missed during the session. And I think that for today, we'll part our ways, and we'll see you soon. Thank you so much. Thank you, Arkady.
Thank you very much. And you all stay safe and well during these challenging times.